Yeah.
Haha. Same day, same shirt. Different lesson, different hat. How about this, huh? Very creative, huh? Okay, so here we go. Remember, when you're doing foil here, first, outer, inner, and last. And these two canceled because negative 4x plus 4x is 0, and we had this answer. Those were shortcuts if you used them. Okay, so if I apply the shortcut here, we multiply the first terms. 2x times 2x is 4x squared. And we know that this one will eliminate with this one. And negative 1 times 1 is negative 1. Those were the shortcuts. Okay, now I'm going to give you this part, and you have to factor it and come up with this one. And we call those difference of two squares. What's the difference? A subtraction. Here it is, and here it is. And two squares. Here's one perfect square, and here's the other one. 16 is a perfect square, and x squared is a perfect square. Here's one perfect square, and here's the other one. Why is 1 a perfect square? Because 1 times 1 is 1. 2x times 2x is 4x squared. All right, so keeping that in mind, let's factor. I always look first what you learned first. Do I have a greatest common factor? If I don't have that, then I see if it's a difference of two squares. So let's check this one out. Do you have a greatest common factor between 16 and 9 or x squared? No, there's nothing. So let's see if it's a difference of two squares. Is it a difference? Yes, it is a difference. Of two perfect squares? Well, I think so. So if it's a difference of two squares, it's going to be one positive and one negative. It doesn't matter which one goes first. And then we take the square roots. What's the square root of 16x squared? 4x. And what's the square root of 9y squared? 3y and 3y. If we FOIL this, we get the original answer. Do we have here a greatest common factor? No. Is it a difference of two squares? Well, yes, it is a difference. Are these perfect squares? I believe so. So I know that my answer is going to be 2 parentheses, 1 positive and 1 negative. What's the square root of x squared? X. What's the square root of 16? 4. And this is the factored form. Do we have a greatest common factor? No. Is this a difference of two squares? No, it's a sum. So this one is what we call prime. We cannot factor it. Okay, first, do I have a greatest common factor? No. Is it a difference of two squares? It is a difference, and these look like perfect squares. So it's going to be a positive and a negative. What's the square root of x to the 4th? X squared. And what's the square root of 25? 5. And that is your answer. Do we have a greatest common factor? Oh, yes, we do. What's in common here with 5 and 45? 5. And between x to the 5th and x, we have 1x in both of them. So now we're ready to divide. 5x to the 5th divided by 5x. These cancel, and it's x to the 4th. Because 5 minus 1 is 4. 45 divided by 5 is 9, and x divided by x cancels. Oh, but I think we can continue factoring, because this is a difference of two squares. So we bring this down because we have to bring it down, and here we are going to keep factoring just this parentheses. Since it's a difference, it's going to be a positive and a negative. What's the square root of x to the 4th? X squared. And what's the square root of 9? 3. And this is your final answer. And the last one. Do we have a greatest common factor? I believe we do. And it is negative. Since this one starts with a negative, I'm going to put it right here. Y. I have y's in both of them. So I'm ready to divide. Negative divided by negative, positive. 4 divided by imaginary 1 that is there is 4. And y to the third divided by y is y squared, because 3 minus 1 is 2. Positive divided by negative, negative. 9 divided by 1, 9, and the y's cancel. I believe we have a difference of 2 squares again. So bring down this negative y, and we factor this completely. Positive and a negative. What's the square root of 4y squared? 2y and 2y, and the square root of 9 is 3. And when we multiply all this out, we should get this. But this is our final factored form answer. Alrighty, until next week. Bye-bye.